Section 6.2 is about solving quadratic equations by graphing. When you take a quadratic function and you set it equal to 0, specifically in this case equal to 0, you create what's called a quadratic equation, and quadratic equations can then be solved. Now, the word roots is one of the words we use to talk about the solutions of a quadratic equation. The word 0 is also a word. So roots, zeros, and solutions are all three words that we use to describe the place where a parabola crosses the x-axis. So if you see here on this example, the parabola will touch the x-axis at these two spots, at 3 and at 1. Those are said to be the solutions, or the zeros, or the roots of the quadratic equation. And that's what we're going to be finding. We're going to find the place where any parabola will touch the x-axis. Here we want to solve this quadratic equation by graphing. One of the best ways to start is to start with the axis of symmetry. The formula for axis of symmetry is opposite of b over 2a. In this case, my b is a 6 and my a is a 1. So we find out that our axis of symmetry is x equals negative 3. I'm now going to use that x value and plug it in to solve for what the y would be, and then I can find my vertex. So this is a 9 minus 18 plus 8. So negative 9 plus 8 would be negative 1, which means my vertex is negative 3, negative 1. So now I'm going to graph my vertex, which is right here. I know because the a is positive, it's a positive 1. I know because of that, the parabola is going to open up. So now I'm going to figure out some other points that are on this parabola, and I'm going to do that by building it around my vertex negative 3, negative 1. That means I'm going to go to the left of it and try negative 4, negative 5, and I'm going to go to the right of it and try negative 2 and negative 1. Why don't you pause the video and try to plug in these x values and figure out their y's, and then come back and see what the solution is. So here I've done the work for negative 4 and negative 5. When I plug in negative 4, I get a 0. And when I plug in negative 5, I get a 3. Now, because parabolas are symmetrical, we know that the y value then has to be a 0 for the point on the other side of the vertex. And we also know that the y value that's 2 units away has to be 3 on the other side of the vertex here at negative 1. So I'm going to finish sketching my parabola by graphing these 5 points. And now I've got to go back, and the directions asked us to solve. Well, solving the parabola is finding where it touches the x-axis. I see that the parabola touches the x-axis here at the point negative 2, 0, and I see that it touches the x-axis here at the point negative 4, 0. So we would say that the two solutions are negative 4 and negative 2. In this key concept, we see the 3 different scenarios that can take place when you graph a parabola and you try to find the number of solutions. The one we've already looked at is right here. You can graph a parabola and find out that there are 2 solutions, 2 places where the parabola touches the x-axis. But there's also a possibility that the parabola will only touch the x-axis in one place, and therefore will only have one solution. But the parabola could touch the x-axis nowhere, and in that case we'd say that it has no solution. These are the 3 possible scenarios that could happen when you graph a parabola. You could have one solution, 2 solutions, or no solutions. Here we're going to solve this parabola by graphing. The first thing that I notice is the parabola is not in the proper order and everything is not on the same side. So I'm going to subtract 16, and then I'm going to rewrite this as negative x squared plus 8x minus 16 equals 0. You have to have it equal to 0 if you're going to solve it, and it has to be in descending order. Now I'm going to find my axis of symmetry. My b here is 8, so we're going to use the opposite of 8 over 2 times a. My a is negative 1, so we end up with an axis of symmetry of positive 4. Now we'll plug that in for the vertex. So we square the 4 first and then make it negative. And we end up with a vertex of 0, which means the ordered pair 4, 0 is my vertex. Now if I graph that, I find out that the vertex is right here, and I know because the a is negative that my parabola is going to open down. Now here's where I can save myself a lot of work. I don't even have to finish this problem because I know the vertex is here, which means it's the highest point. It's a maximum. It's not going to go any higher. I know the parabola is going to open down, so I know that there's only one solution to this quadratic equation, and it's right there at 4, 0. So I can say my solution is 4, and I'm done. Our last example, we're going to graph, we're going to solve it, and we're going to find that the roots are not going to be perfect whole numbers, and I'm going to show you how to deal with that at the end. What I would suggest is that you pause the video and try to graph this quadratic equation on your own, then come back and see the work. So here's the work, finding axis of symmetry by plugging into the formula. You get a 2, plug that 2 in and find that the vertex is at 2, 3. So I'm going to graph that. I know my parabola is going to open down because the leading coefficient is negative, so I know it's going to go down here somewhere, so it's going to touch the x-axis. I know that. So I put the vertex on a table, and I'm going to find 2 points smaller than that and 2 points bigger than that. Well, I plugged in 1 and got a 2, and I plugged in 0 and got a negative 1. I know because of symmetry that there's got to be a 2 down here also, so 1, 2 also has to have a 3, 2. And 0, negative 1 means I better have a 4, negative 1 also. Graphing all of those points, I got 1, 2, and 0, negative 1. And then I have 3, 2, and 4, negative 1. Now when I sketch this, I want to be careful to go through each point. Okay. Now, I'm looking for solutions, which means I'm looking for where the parabola will cross the x-axis. Well, it looks like it crosses right here and right here. The problem with those two spots are that you don't know exactly where it touches the x-axis. So when you can't tell for sure, what we want to do is we want to say that it's between 0 and 1. So we're going to write that this way. We're going to say 0 is smaller than x, which is smaller than 1. This tells me that my x, my solution, is between 0 and 1. Well, it's also between 3 and 4. So we'll say 3 is less than x is less than 4. This is called estimating solutions. I don't know exactly what they are, but I know they're between 0 and 1 and between 3 and 4.